figure shows a conducting disk rotating about its axis in a perpendicular magnetic field. A resistor of resistance R is connected between the center and the rim. We have to calculate the current in the resistor and its direction. Now I do have some of the data, that is the radius of the disk is 5 centimeter or 0.05 meter. Omega is given as 10 radian per second. Resistance is 10 ohm and magnetic field is 0.4 Tesla. Now the best way to solve this question is assuming that instead of a disk I do simply have a rod of radius of length equal to the radius of the circle, that is R, and it is rotated with an angular velocity omega in this direction. So we know that when a rod is rotating with an angular velocity omega, then the EMF induced in it is given by B omega L square by 2, where L is the length of the rod. Now apart from the question, let us deduce this formula that let's suppose this is my rod of length L, pivoted at this point and rotating with an omega. So let us assume that there is a small length dy at a distance y from the pivot point. So I can write, let's suppose that velocity of this small part is v in this direction. So I can write small EMF induced, that is dE, is given by BVL, that is B into velocity into length of that small part, that is dy. Now magnetic field is B, no doubt. Let's suppose inside velocity will be given by R omega. So here R is y into omega into dy. So integrating both sides, the value of y varies from 0 to R. I get the answer is B omega R square by 2. So I'm using this very same formula over here. So I do have the EMF generated. So simply substituting all the value, I have magnetic field as 0.4, omega as 10, length that is equal to radius given by 0.05 whole square divided by 2. This is the EMF that is generated. Apart from that, to check the polarity of the battery, again the omega is in this direction, so velocity will be in this direction. So use the same concept, V cross B, that is the force acting on the charge present inside this rod. So by V cross B I get that positive charges are accumulated over here, negative charges are accumulated over here. So clearly this point is at higher potential, this is at lower potential. So my battery is like this. So clearly current is going in this direction. Fine. Now current is given by Ohm's law, that is V by R. So simply substituting the values, we have resistance as 10 ohm. So on solving this, I get the value of current 0.5 milliampere, and that is the answer. And if we talk about the direction, then I told you that it is flowing in this direction. So from the center it is leaving, so it's leaving the center.